Ladies and gentlemen, I am Steffen Büttner from the Department of Geology, and I welcome you to the Science Extended Studies Program module on geology. This course is based largely on the textbook Earth's Portrait of a Planet by Stephen Marshak, which I think is now available in the 6th edition. And Portrait of the Planet is a fantastic, very comprehensive textbook that also covers our first year geology course and a lot of material on all aspects of geosciences. Beyond that, if you want to major in geology or in geography, it would be a good investment to buy that book. I believe you have been given a number of sections from that textbook, and you probably will see how good it really is. Geology and geological processes, you might have heard the term of the science. It comes from the Greek term ge, which simply means earth, and logos, study. We study the earth and its evolution. We look at the rocks of which the earth is composed, and we look at the process by which the earth evolves, by which the rocks are forming and change over time. This is what geologists are doing, and here are a number of fields that we are particularly might be interested in, and that is obviously the history of the earth. There is a model that is called plate tectonics. You might have heard about that too, and that helps us to explain most geological processes on Earth. Not so much on other planets, but Earth is special in a number of respects, and particularly the process related to plate tectonics is something that happens only on few planets that we would know of. The evolutionary history of life is another subject field, paleontology, that's what it's called, and it deals with the origins and the evolution of time since the early beginnings of the Earth. The earliest traces of life are 3 to perhaps even 4 billion years old. And in the last 500 or 600 million years, higher developed life has existed, and paleontologists study this. Then, of course, the exploration of mineral and hydrocarbon deposits is an important field, and with increasing significance, groundwater resources. So, exploration geology, hydrogeology are two very important fields. Understanding natural hazards, you might have heard about volcanism, obviously, earthquakes, landslides. You might even have seen some in parts of South Africa. These natural hazards are also a concern of geological research. Remediation of environmental problems in densely populated areas, this becomes more and more important. Geotechnical engineering, if you want to build large constructions like bridges or dams or big houses or power plants, you need to understand the geology of the area and the ground on which you want to build your construction. And a more recent field in which geoscientists are active is obviously the investigation of climate change in the past and also in the present time. The two fields in which most geologists find employment is the discovery and exploration of mineral resources and of groundwater. I wouldn't be surprised if by now more geologists work in the groundwater business than in the mineral and hydrocarbon business. So hydrogeology is becoming more and more important. And also these two fields, remediation of environmental problems, that is something where geologists can help, and in the engineering field. What do you actually know about geology and geological processes? If you ask yourself, what would you associate with these terms? And obviously, there are a number of things that you have heard about volcanism. We have mentioned that before. Wherever lava reaches the surface, you form volcanoes. And that is, of course, an important geological process. If you look at the news, every few weeks you will hear about earthquakes, and sometimes these earthquakes are associated with tsunamis. Meteorite impacts, something that fortunately doesn't happen all the time, certainly not the big ones, but this is also something that is in the news every now and then. Formation of ore deposits, of course, if you use anything made of metal or of rock, it originally comes out of the ground. And continental drift is a process you might have discussed at school. The continental plates that form the Earth are mobile, and continental drift is the term relating to that. And of course, the formation of mountain belts. There is a good reason why there are mountains in some areas, and in other areas you might find rivers and flatland, or you might find the sea. All that is controlled by geological processes. For instance, mountain belts that are formed, that exist today, will be destroyed over time by erosion and transport of that material away from these mountain belts. We are going to talk about that in the next sections. The course outline here is fairly simple. It's here not structured in numbered chapters, but these are the topics that we want to cover in the lectures that you will be able to listen to on these MP4 files. We're going to talk about the different rock types, the sedimentary, the igneous, and the metamorphic rocks. These are the three important groups, and we are going to learn what they are and how they actually form, in which kind of environments they form. And that will bring us to the rock cycle that will explain how the sedimentary and metamorphic and igneous environments are interconnected on planet Earth. There is a driving force that explains why that happened, and this is plate tectonics. And we are going to talk about that only in very, very short form. You will get a very comprehensive course on that in the first year of geology if you choose to major in geology. In the last section, then, we focus on one of the important geological processes, that is volcanism. It's quite spectacular, and we are going to learn what kind of different types of volcanic eruptions may occur and why they occur in specific places. There are a number of practical assignments which you will do on a weekly basis. We are going to look at topographic maps and their interpretation, at cross sections and measurements on these maps. There will be a field trip around Grahamstown where we can look at a few rocks and structures that are nicely exposed here in the region. And then there will be a bit of a fun prac using the Google Earth software. The resources available to you are the PowerPoint presentations on which this course is based. This is a guide for learning, but obviously it is by far not enough. The textbook will help you a lot. There is a library of books. The internet has a lot of sources on basic geology, and also the audio lectures obviously will be a very important tool for you to navigate through the content of this course. Your lecturers are there to help, but here at university you are expected to work as independent as you possibly can, and before you ask questions you always should try to answer them yourself to figure out what you might not understand on the first attempt. But of course the support is there to be used, so please use it. The textbook, and we are referring here to the 5th edition of this textbook, has a number of sections that are particularly important for this course. Here they are listed. Please have a good look at that. That is where you find the background information to what we are going to talk about here.